Yes.
Yes.
Hello.
Yeah.
Hello.
This
Yeah,
is
right.
Kenneth. So
Sir, you are loud and clear.
Is taking the audio out.
Hello. Yes,
Just
I
hold
can
on.
hear you.
Hold on. Hello, we are back again. Briefly, I just want to know where we are connecting from before proceed.
Connecting from Delta State.
Hello.
Hello, can you hear me?
connecting from Owerri.
Okay, Patrick, can I hear from you?
Connecting from Delta State.
Hello.
Hello, I said connecting from Delta State.
Okay. It's okay. It's okay. Okay. Let's just proceed because of time factor. Let's just proceed. Now we'll start with our cybersecurity basics. As the entire schedule was dropped in the WhatsApp platform, so from there we'll pick it up. I believe everybody here has some basic installation that they've installed in their PC. Asks us to make sure we have Kali running. We should also have Metasploit, Cisco packet tracer running, and Wireshark, which is built in Kali Linux. So work with these particular applications in the whole program. Today we'll be exploring the different concept of networking and cybersecurity fundamentals. So you all know cybersecurity is all about making sure the digital space is secure. And majorly this cyber, we have the blue team and the red team concept of the cybersecurity. And any cybersecurity expert should anchor on core CIA triad. When we talk about CIA triad, what do you mean by CIA triad? We'll talk about CIA triad. We are looking at, just hold on. Okay, we want to talk about CIA. Just hold on, there is a mix of somewhere here. Just hold on, please. Um, okay. It's not still giving me what I want. Okay. Okay. I want to talk about the CIA. CIA triad stands, C stands for confidentiality, I stands for integrity, A stands for availability. So the duty of every cybersecurity expert is to make sure that the CIA is enforced. Information moving through the network should be confidential. A third party shouldn't have access. There shouldn't be any sniffing capability. Integrity simply means the information flowing through the internet space should be intact. Availability simply means at any point in time that users want to access the information via the wherever the information is, it should be available. That is CIA. The duty of a cybersecurity expert is to make sure that these things are enforced in the network. When it comes to we have what we call the that is the reverse of the whole process. Attackers, their duty is to make sure that they reverse this whole process of the CIA. That is, instead for it to be confidential, it should be disclosed. So the information shouldn't be available at any point in time. That is what we call disclosure. So confidentiality makes sure that the information should be intact. That's confidentiality. The duty of a cybersecurity expert to make sure that the information should be confidential. But the duty of an attacker is to make sure that this confidential information should be sniffed or should be made available, exposed to a third party. Integrity simply means as the information is moving through the internet space, it should be complete. But with the attacker, the duty is to alter. That's alteration. A is for alteration. Is to alter this information. They also have what we call availability. Availability means at any point in time you want to access your services over the internet or the network, it should be available at all times. But the duty of an attacker is to make sure that this particular information shouldn't be available. That is, we'll talk about denial. So that here simply stands for disclosure. Is the opposite of confidentiality. A is alteration, is the opposite of integrity. A stands for availability. Then D, to counteract it, it is denial. This is a basic concept. This is where cybersecurity revolves. So, having understood this basic concept, our lecture will be more of practical. The theoretical aspect will just be basic. I said 20% theoretical. Then we'll go further with what we call the cyber keychain. Cyber keychain. A cyber keychain is simply, let me just give us a pictorial representation of the cyber keychain so that I'll know what it's all about. A cyber keychain. So let's get a picture of the cyber keychain. Let me give us the picture. Let me just share my screen once more with the cyber keychain. You just see this, watch at the diagram. The diagram that I'll put on the screen, which is this. There's a cyber keychain. Yeah, if you look at this, I don't know if you can see my screen. This is a cyber keychain. There are phases that this is all about. So there are phases. If an attacker wants to execute a particular attack, there are phases that the attacker needs to go through. The first phase is reconnaissance. The attacker will gather information concerning what he or she wants to launch the attack on. So once you gather information using reconnaissance, now the next phase here is weaponization. Once the attacker must have gathered sensitive information about the target, he or she will now know the type of weapon that can be used in order to execute that particular attack. So the second phase here is what we call weaponization. From weaponization, that is, the attacker will develop payloads, malicious codes in order to launch it at a particular target. The next phase, if the attacker has designed the weapons, the attacker will look for a means to deliver this weapon. We'll talk about delivery. So first, the attacker will gather information, look for vulnerability, look for loopholes, then look for weapons that can be able to use to exploit these loopholes, design the weapons. The next phase, the attacker will look for a way to deliver it. The attacker can use phishing links or different platforms to deliver these particular weapons. Once the attacker deliver this weapon, the attacker will make sure that this weapon is being executed at the target. Either the target, it will allow the user to click on the particular thing for this particular payload to run behind the scene, or the payload itself can run. Once a process is running in the system, the payload can start running. So once it starts running, this payload now will start exploiting the vulnerabilities that are in that particular target. Once it exploits the vulnerability, the next phase in this cyber keychain is what we call action on objective. Therefore, if this payload that is being installed at the target system is being successfully launched, it will exploit the vulnerability, the loopholes, then the objective of that particular attack will now be achieved. That's what we call action on objective. Now, once the objective is being achieved, the last phase is what we call, command control before action on objective. So have command and control. So if installation takes place, exploitation follows, command control, that's what we call C2. That is, the attacker can stay at his or her own end and be controlling the target system. That's what we mean by command control. There are different ways that this can be executed. Netcard is a tool. It's a platform that you can use, for example, to execute some of these command control. At the end, maybe the attacker wants to transfer files. With the help of Netcard, which is a tool, the attacker now can transfer files remotely to the target, to his own destination. At that point, we say the objective has been achieved. So cyber keychain simply tells us the phases that the attacker follows in order to execute the attack. First of all, it will gather information. Once it gather information, it design the weapons. Once it design the weapons, look for a way to deliver this weapon. Once it deliver the weapon, the payload, for example, payload and malicious code will be executed at the target. Once it's executed at the target, it will exploit the vulnerability that is available in that target. Once the vulnerabilities are exploited, now we'll have what we call command control. The attacker will be controlling the target from his or her own location. Then we now say the objective has been achieved. That is what we call the cyber keychain. Another thing which we also need to understand here, which is also more of like a framework again, we have the MITRE attack. MITRE attack is another phase in which is a platform, let me put it like that, it's a platform that both the red teamers, these are the offensive people that are always there to cause malicious harm to the system. The blue teamers are people that are there to defend the system. So MITRE attack framework is a framework that gives us the entire phases. For instance, you want to execute an attack, you don't know how to go about it. You can follow the MITRE framework. Let me just give us a picture of the MITRE framework. MITRE framework so that you get it. It helps both the red team and the blue team person. So have MITRE attack. Let me go to the website. MITRE attack is an awesome resource that will help you both as a red teamer or a blue teamer. So I don't know whether my screen is visible. If you can see my screen, you just give me a thumbs up there. I don't know whether it's visible. Can you see the MITRE attack? Okay, fine. If you can see, let me explain, because this will help you as a cybersecurity professional, both as a red teamer or a blue teamer. Now, in every cybersecurity sphere, there is what we call the enterprise, the mobile, and the ICS. Now, when we talk about mobile, we are trying to see how we can secure the mobile platforms or to launch attack on mobile platform. The ICS, which stands for Industrial Control System. Now we have things like SCADA. We have platform machines that control the entire industrial process. So attackers will also be trying to launch attack in such platform. We have enterprise. These are big organizations. How can you secure big organizations? So now there are phases or there are stages that you need to follow, both in defensive mechanism and in offensive mechanism. Now, in this whole process here, let me just click on the enterprise first. Let's look at enterprise. Once you click on enterprise, in every MITRE attack process, there is what we call tactics and there is what we call techniques. We have tactics. Let me go back to the, I think the matrices here. Let me go to the matrix here. There's what we call tactics. There's what we call techniques. Now, before an attacker launch any attack, the attacker must have something in mind. For instance, let's say, look at these phases here. We have reconnaissance, we have resource development, initial access, execution, persistent, privilege escalation, stealth, and defense implementation. Yeah, these phases, there should be more than this. The phases here should be more than this. Should have more than these. Why is my screen not sizable here? Okay. Yeah. So these are the phases here. We have close to, they're about, let's say, yeah, there are, yeah, these are all of the phases here that are involved in these processes. So we have impact, exploitation, command control, collections, lateral movement. So each action that you want to take, you will come through these phases here. In this MITRE attack framework, you study the tactics and the techniques. The tactics here tells us about the why. The techniques is the how. So the tactics is the why. Why do you want to do this? The techniques is how do you go about your why. Now, reconnaissance is just all about gathering information. It can be passive information, it can be active information. Passive information is gathering information without the user's consent, while active information is with the you are engaging with the target. So if you want to gather information here, you gather, go to reconnaissance. With reconnaissance, if I click on this reconnaissance, these are the different techniques that I will use. So my goal here is to gather information. How then, these are the techniques I will use to gather this information that I want to gather. So if I click on this, for instance, I click on instance. Now, this reconnaissance now is the tactics. Then the techniques, how do we go about it? So for us to go about it, these are different ways you can go about it. Now, you look at active. You can use active information gathering. You click on it, you study how you can go about this active information gathering. If I click on how to go about this active information gathering, in this, there are things that you can use. And these are the procedures that you follow down here. It gives you the procedures. So these are the procedures here that you can use to go about that particular information gathering. So these are the sub techniques. This is a sub technique. So if I want to gather information concerning the blocks of IP addresses, or I want to scan for vulnerabilities, so these are the sub techniques that I can use. It will give me the sub techniques. So it tells me what I should do concerning this for this particular sub technique. That's I want to scan blocks of IP address. You read more of this, it gives you a guide on how to go about getting that. But if you're a defensive person, how do you mitigate it? The ways in which you can defend this particular tactic. So you look for all these ones here, there are different mitigation strategies that you can use. If you want to protect that particular platform, you click on this. If you click on this, it gives you an insight on how you go about the mitigation. So the mitigation is a limit information exposure. So with this, it gives you a guide on how you can defend the organization about for users or attackers not to gather information more concerning the IP address. So we have talked about tactics, we've talked about techniques. So these are the general concept when it comes to MITRE attack. It gives you a guide on how to follow in order for you to execute a particular attack. Or if you want to defend, how do you go about your defensive mechanism for you to defend that particular process? And the last concept here we are going to look at here is the CEH methodology. CEH methodology. Now, these are phases that, as a certified ethical hacker, what are the phases you need to follow in order to execute your process? As a certified ethical hacker, there are phases you need to follow. I will still show us the diagram, then we'll now switch into some other aspects. So I'll go here straight. I'll show us the diagram of the phases. CH methodology. If you're a certified ethical hacker, there are phases you need to follow. I would like to give us an image of those phases. These are the phases. Let me take this. Let me take these phases. Let it come up properly. Yeah, these are the phases. If you can see my screen very well. As a certified ethical hacker, the first thing, you can't attack without gathering sensitive information. So the first thing is for you to gather information. Once you gather information, the next phase, based on the information you've gathered, you can now move into what we call scanning. To scan your targets, to know what is actually happening in the target using some tools. Once you scan your target, the next phase, you need to move from what you've scanned. If you discover that the target is vulnerable, then you can now gain access from what you've scanned. You might discover that the password is not strong. They use passwords that are not so effective. Scanning gives you access to discover more vulnerability about the target. Then from what you've scanned, you can now gain access. From the vulnerability, you can now gain access to the particular target. Once you gain access, what the attacker will do is try to maintain access in that particular target. There are different techniques that you can use to maintain access. Now, once you maintain access, you can now be doing what we call privilege escalation, what we call post-exploit. Post-exploit is an exploit when you've arrived at the target. You can now move around the system. We have what we call lateral movement. If you want to execute lateral movement, you can still go to MITRE attack framework. It will give you the phases how you can go about your lateral movement. Lateral movement simply means once you are the target, you cannot gain, there's what we call escalation of privilege. That will now, you might have access to a super admin. From the super admin now, that can control other users. You can move now within the network. That is maintaining of access. Then the next phase here is what we call covering of tracks. Covering of track now simply means you don't want your traces to be discovered. Everything you've done, you look for all the tactics or the methodologies in order to hide your tracks or to hide the activities that you've executed. Having understood this, I want us to move straight into the concept of networking, because today we'll deal majorly on networking. So let's move straight into the concept of networking. Moving to networking, I'll return back to share the screen. Please also don't let me unshare my screen. So that let me use my notepad. Okay. Sorry. Okay, let me go. Let me take a text here. Okay, we'll look at networking concept. Now, with this networking concept, I'll highlight some networking connectivity devices. Then we'll move to, let's look at connectivity. Now, for every network to work, there must be connectivity devices. And this connectivity device helps for flow of information within the network. The first connectivity device I want us to look at here is the NIC. That's the network interface card. Now, the network interface card is very important when it comes to networking. The network interface card can either be wired or wireless. Now, every network interface card has a built-in address we call the MAC address. The MAC address is a very important address when it comes to our network devices. The MAC address is built in every network device. Every network device has a MAC address. The MAC address helps devices to communicate to one another within the local area network. The MAC address is a format of a MAC address. A MAC address is written in hexadecimal. Hexadecimal is simply a combination of numeric value and alphabet from 0 to 9 and A to F. And we have something like this. This is a combination 0 to 9 and A to F. That is hexadecimal. Now, we can craft the MAC address. As a cybersecurity expert, you need to understand the MAC address concept, because there are times you can clone your MAC address using MAC changer. So how does a MAC address look like? Let me just derive one MAC address here. A MAC address is represented in 6 bytes. 6 bytes, what do you mean by 6 bytes? I will design something like this. 1, 2, 3, 4, 5. Yeah, these XX here, these are just placeholders I place here. It means if you want to create a MAC address, you can choose number between 0 to 9 and A to F are represent in this position. You can randomly create your own MAC address. If I want to create my MAC address, what I'll do here, I can say AC, for instance, BD. You can randomly choose number between 0 to 9 and A to F. I can go for that, I say 0C. I'll go for that, I say 2, 3. I say DD. It shouldn't exceed 1, 2, 3, 4, 5. It shouldn't exceed 6. That's 48 bytes. 8 bytes, 48 bit rather. I can say B. This is a MAC address. This is just a simple MAC address. This is a MAC. Every device that goes through the network has a MAC address. So this is a MAC address, and you need to understand, because you can clone MAC address. You need to understand MAC address because there is an attack that is called man in the middle attack. It is MAC address is being used to execute such attack. So you can clone your MAC address. You know how a MAC address look like. In every MAC address, you know, we have 6 sections here. This section will call the AUI. This other section is what we call the vendor assigned. So MAC address is built inside devices. Let me quickly show us, let me practicalize how you can visualize a MAC address in your system. Now, I will quickly, let me take Windows first. I'll show us where we can get the MAC address. You go to your CMD. I'll go to my command prompt, CMD. When I go to my command prompt, I don't know if you can see my screen. If you can see my screen, you give me a thumbs up. If you can see my screen. Okay, can you see this black screen? If you can see the black screen, you just say hi. Let me get a feedback. Can you see the black screen? You just type hi. Let me get feedback. Can you see the black screen? That's my command prompt. Can you see it? I'm not getting.
No.
Okay, down. That means you are not seeing it. Let me reshare. So let me reshare. If you can see it, you can thumbs up for me. Let me know that you are in track. Okay, fine. Somebody's following. So yeah, if I want to see the MAC address of my system, there's a command I'll type.
You can't see it though.
ipconfig. I'll press enter. Now, once I type ipconfig and press enter, you move somewhere. Let me go to my Ethernet. Let me use /o. I'm getting IPv6 here. I don't want IPv6. Let's use ipconfig /o. Yeah, it will give us a perfect look. So this is an example. This is a Bluetooth. Is used for Ethernet. Oh, sorry, used for networking. Let me go to this wireless. This is my wireless LAN card. This is a MAC address. If you can see how it looks like here, is as I crafted it, that's how it is. It is made up of 48 bit, which is equivalent to 6 byte. Each of these is 4 bit. So this is an example of a MAC address. This is for wireless. Your phone also have it. So these are all examples of a MAC address. It is a combination of numbers and alphanumeric. So we are not talking about IPv6 now. These long ones are all IPv6. These ones are all IPv6. So we're not talking about that for now. So MAC address is very important in this process. Now I say it's built in inside every NIC. Let's leave MAC address. Let's switch to another network connectivity device. I'll return back to okay, let me show you how you can get it in Kali. We are demonstrating practical. I hope those that have Kali on, we can also see how we can get it in our Kali. I believe our Kali is on. You can see how we can get the MAC address in our Kali. Let me share my Kali screen. I believe you should be able to see my Kali. I'll go here. I'll go to my terminal. I increase the screen. Yeah, in my Kali environment, for me to see my MAC address here, I can just type IP route. If I type IP route, it's not connected. Let me connect. There's no network internet here, access here. Let me just connect. Okay, that's come. Now this IP route. Okay, let's use if config rather instead of IP route. There is if config. If config should give us an idea. Yeah, this is my ETA1. You see, this is a MAC address here. As I explained, this is a MAC address. It's an example of a MAC address. So that is how a MAC address looks like. So I've shown us how to easily trace a MAC address in our system. I'll quickly move to next connectivity device in our networking, which is we'll talk about switch. Switch is very vital in our network. I'll talk about switch. Let me go back to my notepad. Let's talk about switch here. Switch majorly let's hold on. Okay, we'll look at a switch. Switch is important in our network. What is a switch? Switch is used majorly to link two or more devices together within a LAN. And now, as a cybersecurity personnel, for you to be good in defending or attacking, you should know how things work. You can't succeed in cyber without understanding how things work. So switch, it is just used to link two or more devices in a LAN. Now, in a switch, let me see if I can give a sketch of a switch. See, I can give a sketch of a switch. Let me just take a new slate. Okay, let me sketch a switch here. It's just a sketch. These are devices linking to this switch. Now, every switch has what we call a CAM table. CAM. CAM. CAM stands for Content Addressable Memory. If devices are connected, this, let's say device A, let's say device B, this device C. Now, if they are connected in a network, each of these devices has a MAC address. I just explained what is a MAC address. Each of these devices has a MAC address. Now, the content of this CAM table, called a MAC table, also you can also call it a MAC table, or the CAM table, content addressable memory, or media access control table. So this table stores the MAC addresses of every device in a network. So once a switch is powered off, each time you put off a switch, this memory is empty. And once you power devices in the network, a switch will send what we call a broadcast. There's what we call broadcast. Broadcast, BC. Broadcast is a message that is sent across all devices in this network. A device A wants to talk to device C, for example, in this case. What they use MAC address to talk to each other. It's just like a phone number. So once this switch, the memory is blank, if A wants to talk to C, A doesn't know the MAC address to communicate with C. So A will send a broadcast. There is a broadcast address of OF. It uses a broadcast address of OF. FF is in the form of MAC address. FF, this is what it uses. This is what it uses. It should be 6. It uses this MAC address to flood the entire LAN. Once it floods this LAN, it is demanding for the MAC address of a particular device it wants to communicate with. And once this device sends the MAC address, it will definitely place it in this MAC table. Now, in this case, once A floods a signal that I want to talk to Stevie, I don't know where she is located. She cannot get your MAC address. But funny enough is, within the LAN, we assign IP address, but devices don't use IP to talk to each other in a LAN. They use IP to communicate outside the LAN. So if they want to talk to each other, they need MAC. So there's a protocol. Protocol is simply a rule that governs communication in the network. The protocol is called ARP, A-R-P. A-R-P is a protocol that is used to resolve a non-IP to get the MAC address. What do I mean by that? A wants to talk to C. C has an IP address, but it doesn't know the MAC address. So what will A do? A now, with the help of app, it will send a broadcast to get, once it sends the app at protocol is initiated, it will not get the MAC address of the existing IP address of this PCC. Then it will place it in a MAC table. Once it is placed in a MAC table, at that point, there's what we call convergence. The devices now can talk to each other. But there is an attack that can be executed in this whole environment. This attack is what we call man-in-the-middle attack. Man-in-the-middle attack simply talks about, let me say this PC, let me increase, let me increase this a little. Okay. Hello. I don't know. What's the? I think somebody has an issue. Gabriel, can I get your issue? Can you type it, or if you can speak, please, you can speak loud, or you type. Gabriel, I'm listening. Either you type or you speak so that I can proceed.
No, sorry, continue. I went to ask
Unmute
something
yourself
else.
and speak.
I'm speaking. Can't you hear me? Hello?
Speak out. Let me get you again. I can't get you.
Can you hear me now?
Gabriel, can I proceed? Okay. Let's go ahead with I was talking about an attack that can be executed within this LAN. The attack that can be executed within the LAN. Let's say PC. Let me reduce this a little. This PCA, please don't mind my drawings. Just follow me. PCA wants to talk to PCC in this network. The MAC address are already here. Let's say MAC A for system A, MAC C for system C. Now, an attacker comes in between this communication. We'll call this an attacker. It's a man in the middle. How will the attacker come in between? The attacker will use a sniffing tool and use a sniffer. There are sniffing tools like we have EtherCap, BetaCap. These are tools that can be used to sniff, for example. Now, once EtherCap and BetaCap is set up in Kali, the conversation between and C, the attacker will capture the conversation. Remember, A knows where he's going to, which is C. And there's what we call the app table, the app. Address resolution protocol table. Now, with this app maps the MAC address to every IP address. Remember, initially, every device in the network, whether you give it an IP address or you don't give it, there is an IP address by DHCP. If you give it manually, fine. DHCP IP can still be running. So, with that IP running within the devices, they don't use it to talk to each other. They don't use it to go outside the LAN. They use IP to go outside the LAN. Now, in the app table, every MAC is mapped to its IP address. Every MAC is mapped to its IP address. So PCA has its MAC address as well as its IP address. PCC has its MAC address and as well as its IP address. So what happens here is, as A is trying to talk to C, if the man in the middle comes with either EtherCap or BetaCap, any of the two, it will sniff. What it will do here, that tool will help us to change this MAC address of PCC. The attacker now will use that tool and replace his own MAC address here. Once he replaces his MAC address, A knows that, A might just say within himself, and maybe they've replaced PCC. Maybe it's another system with a different MAC address. So what happens now is A now will simply forward the message to this MAC address because they use MAC to talk to each other. This message will land at the attacker's point. The attacker now can now, if that message is not encrypted, it can be altered. That's where alteration comes in. The attacker can alter this information. The attacker can do what we call DNS spoofing. It can redirect. The attacker might create a phishing link. Let's say A is going to a server, but now this thing can be redirected to a fake destination. So thinking that you are going to Facebook, at times phishing link, you can create clone Facebook page, but it's a fake page. Once you click on it, the attacker will redirect everything you are doing. Once you enter, the attacker will capture your password and everything, redirect these things. Now, after he must have seen this thing, he can now redirect it later. So that is what we call app spoofing. That's app spoofing is an attack. Spoofing means you are impersonating. You have app spoofing, you are impersonating a particular thing. So that's an attack as a result of how this LAN and MAC address work. So we shouldn't waste much time on switch. Let me now talk on two other devices. Then we'll switch to the protocols and IP address. Now, a router, what actually is a router? I want us to talk about router here. Router is another important device in a network. Router is another important device in a network. What actually is a router? Now, if you look at the network, we have PC, we have switch, we have router, we can have firewall. This is just a connection, a rough connection. So communication between these is MAC, nothing else. It's a local address. But now, when it comes to a router, the duty of a router now is to link different LANs together. Let's say you have branch A here, branch A, we have branch B of the organization. A router now is a man that can link these different branches together. So router simply links different networks together. The router uses what we call a routing table. When we're dealing with our Cisco packet tracer, we'll look at it. Now, each LAN, each local area network belongs to a network. So the router will keep each of these network in its routing table. Switch makes use of MAC table. Router makes use of routing table. So the router now simply links two or more networks together. That is the duty of a router. And the router here, once you want to get access in and out of a network, there is what we call default gateway. Default gateway. Default gateway is simply the exit and entrance point to a network. If this, let me give two interfaces. One interface can connect to two networks. Let's say this is going to this side and this is going to this other section. These are two different interfaces linking these two branches together. So this section here, the IP address on this router is the gateway. The IP address of this router is the gateway. We'll see it practically when we'll be demonstrating that. Then for firewall, firewall is just used to protect your network from unauthorized access. Firewall is used to protect your network from unauthorized access. That's firewall. A whole lot is involved in firewall. So that is the basic concerning network connectivity devices. Let's look at the OSI reference model. Then we'll talk about IP address. Then we'll switch to the practicals. Now we'll look at, I want us to look at the OSI. The OSI reference model. It is very important, OSI. The OSI reference model, it is simply a model that is used to enable intercommunication and connection of different vendors' equipment in a network. For instance, now, if you want to buy a phone, you won't ask the vendor whether this phone can MTN SIM card work on it or Glow. You just buy a phone. It is open. You can slot in any SIM card. So before now, it was a challenge for different vendors to link up different networking equipment together in a network. So this model, the major duty of this model is to break this barrier. And for this to work effectively, they brought a 7-layer model. A 7-layer model. And this 7-layer model, I will just show you the diagram online to save us the time. I will show you the diagram. Let me stop my sharing so that I'll give you a picture of the diagram. Let me share my screen back. Okay. I think if you can see, this is the OSI reference model, yeah? It is a 7-layer model. Now we have the application layer, the presentation layer, the session layer. This is what we call the software layer. This is the hardware layer, and this is the host-to-host layer. The entire network is encapsulated here. For devices to talk to each other, it works through this OSI reference model. So I'll quickly give a brief on how this model operates. The application layer deals with applications that can give you access to the network. For instance, your Google Chrome, it gives you access to the network. That is the application layer. If you want to access network, once you open Chrome, you type something on your Chrome, instantly, it will give you access to the internet. Now, once you open Chrome, you type something. Once you type, let's say you are Googling for something, the presentation layer will present that stuff that you are looking for. For you, that's the presentation layer. So presentation layer is all about presenting information in a generified format so that there shouldn't be any barrier in a network. It compresses, it converts from one format to another. That is presentation layer. Video itself, there are different formats of videos. There are different formats of pictures. That is the detail of presentation layer. The session layer, the detail of the session layer here, it is to establish session. The session here we are talking about is for if two devices are about to talk to each other, a session needs to be established. It's just like if we have our OTP. If you want to do a bank transfer, an OTP will be established. There will be a time frame for that OTP. I can call that a session. Once that session is established, there's a time that if you don't use it, that OTP will expire. No, session layer establishes session, it maintains session, and it tears down session. So if you don't use that OTP, it will terminate. So the session layer is to create session, maintain, and terminate session. That is the duty of the session layer. The transport layer, on the other hand, it is to move your information from one location to another within the network, the transport layer. So transport layer at this point helps you, for instance, to move packet or fragment or segment from one location to another in the network. That is transportation. And for this to be achieved, majorly, there are two protocols. Protocols are the rules that govern the flow of communication of devices within the network. We have TCP, that is Transmission Control Protocol. And we have UDP, which is User Datagram Protocol. With TCP means for communication to take place, there must be what we call three-way handshake. What is three-way handshake? For three-way handshake to take place, two devices must agree for them to talk to each other. For devices to talk to each other, there must be three-way handshake. Let me show you what is three-way handshake. With a three-way handshake, let me just use this diagram to demonstrate three-way handshake. Now, this is a three-way handshake. Two devices can talk in a network without establishing three-way handshake. This is very vital to a cybersecurity expert, because before you launch an attack, you want to know whether the target is responding or is not responding. You don't want to waste your time to target a target that is inactive. So you first of all know whether these devices are talking to each other. We'll use a tool like Nmap. Nmap will help us and Wireshark to diagnose, to see whether the target that we want to attack, whether it's alive or not. So three-way handshake with the concept of three-way handshake simply says, client wants to talk to the server. Most of the times you are browsing, you send a request. So before that request is being sent, the two devices must agree. So device A will send what we call scene. It's just like beckoning the target. Hello, I want to talk to you. Are you ready? It sends a scene. Now the server now will do what? The server, on the other hand, or the target, the destination, will respond to this scene, thereby giving what we call scene arc. So when we talk about scene arc, it means the server is acknowledging this scene and is telling the client that, okay, I'm ready. I want to talk. That is what we mean by scene arc. And final stage of this three-way handshake, excuse, is the client now will acknowledge the response from the server. This is very, very vital in terms of launching your attack, in terms of gathering information. You need to know how this three-way handshake works. So the client sends a scene, the target responds by acknowledging that scene. So three-way handshake is simply scene, arc, and arc. Once this is established, it means communication can start taking place. But if this is not established, two devices can never talk in a network. So when you look back to our OSI reference model, before transportation takes place, if you are using a protocol called TCP, which stands for Transmission Control Protocol, it uses three-way handshake needs to be established first. The devices must establish agreement before they communicate. So TCP, it is a connection-oriented communication protocol. That means devices must establish their connection, agree before the communication can take place. If communication agreement is not there, the communication cannot take place. Now, on the other hand, we have UDP. UDP also, it is a protocol that it is not connection oriented, meaning UDP doesn't establish an agreement before the devices, or let me put it this way, with UDP, there is no acknowledgement in the sense that if A is sending information to B, even if that information doesn't get at B, the A will not know that this information has not gotten to itself. So, but with TCP, there is always a feedback. There is flow control. There is a feedback with TCP. But UDP doesn't have feedback. It doesn't have acknowledgement. That is how UDP works. Meanwhile, with network layer, what network layer does, now, devices which we discussed before operate at this layer. The router operates at the network layer, which helps devices, different networks to talk to each other. Data link layer is simply a layer that works at the local area network. That is the LAN. That is where a switch is found. It helps devices to talk to each other within themselves. And then the physical layer, which is the last layer here, it talks about transmission media, cables, how devices transmit signal from one point to the other in this segment. So with the OSI reference model, from up to down, we have what we call encapsulation. Encapsulation is a process of enclosing. You know, once you go to TCP, there's what we call TCP header. TCP header means the header there means something has been added to the existing TCP. From up to down in the OSI reference model is what we call encapsulation. Encapsulation simply means as the signal is moving from one layer to another, something is being added in front of it. And that stuff that has been added, we call it a header. So headers have been added in front of, more especially if you look at the first three layers, the software layer, what we call there is data. It is called data. Let me show you a diagram of encapsulation and de-encapsulation so that I get a better picture of what I'm talking about. Encapsulation, we can call it PDU. Let's say TCP PDU. Let's see. Let me see. I can get it here. Yeah, I think we'll have a better picture here. So you need to get an insight before we do some practicals. So these are PDUs. Let this thing come up properly. Yeah, perfect. As the OSI reference model is working, each of the layers, there is a way they understand the network signal. From the top segment, this upper layer, what is seen there, the PD is what we call data. And as it's navigating down to the transport layer, there is an encapsulation that will take place. The entire of this process here, from up layer is data. As these things have been added, this is the header. It's like giving much load to it. So this header now, in the header will have the destination port number, source port number, and so on and so forth. But the PDU at this layer is what we call segment. It is called segment. Once it's navigating to the network layer, the PDU here is called packet. It doesn't understand data. It doesn't understand segment. What it sees here is what we call packet. And what are the headers? The headers of the IP is simply things like this. These are the header. So it's encapsulated. It's covering the main. This what came from the upper layer is segment, but it's been encapsulated. It's been shielded. Now at the data link layer, now at what we call frame. Frame now is the encapsulated packet. And what are those things that makes this data link layer header of frame? We have destination MAC address, source MAC address, and so on and so forth. And what we'll be doing analysis Wireshark. These are sensitive information. You need to diagnose any traffic moving in a network, and these are the things that you should be looking at. If an IP is coming from a wrong source, you will know where it's coming from with the help of Wireshark. So here we have frame, and at the last layer here we have what we call bit. Bit will convert everything to zeros and one and pass it through the cable. That is what we call bit encapsulation. From up to down, it is what we call encapsulation. But if this process is moving from down to up, it is what we call de-encapsulation. De-encapsulation simply means all these headers are being removed. If it is moving from physical to data link layer, zeros and ones are being stripped up. From data link layer to network layer, the frame segment are being stripped off. That is de-encapsulation. Until you now get the final data. That is how these things operate. So that's how OSI reference model work. And another aspect that we need to understand is protocols. Very important. Protocols is very, very important. Protocols, you can't survive in cyber without understanding protocol. Protocol is a gateway in terms of attack. So protocols, at each of these layers, there are protocols that operate at each of these layers. This layer has protocols that govern the activity at each of these layers. So look at attackers are looking at vulnerable protocols. So if you are doing your scanning in the network, you should be looking at protocols that are vulnerable so that you can exploit this protocol. So at the first upper layer here, we have some series of protocol which I want us to look at. I will just list them, then I'll talk about them. I will go straight to my notepad. I think it should be here. I'll talk about these protocols. Let me fall back here. Now, when we talk about protocols, there are a whole lot of them. We look at the protocols that operate at the application layer. Now, basically, we have protocols like HTTP. We have HTTPS. I can't talk about all of them. There are many of them. I'll just list some few. We have HTTPS. We have Telnet. We have SSH. We have FTP. We have DNS. We have POP3. We have other protocols like IP is a protocol, internet protocol. We have protocols like let's say SMTP. These are some of the protocols. We have NTP. These are some of the protocols. This protocol works at the application layer. Let me just discuss on these ones. Now, if you are running a scan, because one duty of or one of the face of an ethical hacker or an attacker is to know what is running at the destination. You can't launch an attack without understanding the level of vulnerability at the target. So HTTP is Hypertext Transfer Protocol. And each of these protocols has what we call port numbers. Port number is another important thing you need to understand. I will talk about port numbers. So port number, they are very, very important. So HTTP is just a protocol that gives you access to a web page. If you want to access internet, it is HTTP. And it makes use of port 80. That's what it makes use of. Each time you scan a target and you see a target running on HTTP, know that that target is vulnerable. You can easily launch an attack on that target. It is simple. One, what are the disadvantages of HTTP? HTTP, one, any information running on HTTP is in clear text. With Wireshark, we can capture every information with that. That's why most of the times when you are browsing, if you open a web browser, you will see a padlock sign at the initial stage or the extreme of your browser. Without padlock, most of the times Google will tell you not secure. So HTTP is a secure version of HTTPS is Hypertext Transfer Protocol Secure, is a secure version of HTTP. With this, there is TLS that has been added, a security perspective that has been added to it. It uses port 443. That's what it makes use of. So with this, it is even the attacker captures the information to an extent. It will be difficult for the attacker to what we call sniff and get what is running in that particular signal that is moving over the network. So HTTP is secure. Telnet, on the other hand, it is a remote access protocol. With Telnet, you can remotely connect to a destination. You can communicate remotely. That is Telnet. But Telnet itself is vulnerable. It is not secure. Telnet uses port 21. Yeah, Telnet should be using, I think 23. FTP is 21. Telnet uses 23. Then we have SSH. SSH, which stands for Secure Share, is a secure version of a remote access. That's Telnet, is a secure version of it. It has more encryption. It has security as compared to Telnet. Now, if you launch your scan, either using Nmap or use other vulnerability tools to know about a target, if you discover that that target is simply running Telnet, it is easy for you to hack the target. Now, SSH is secure. It doesn't mean that it can be hacked, because SSH has different ways in which, if it's being set up, if it's not set up properly, it can easily be hacked. For the attacker now, attacker can scan. Once you get those information, you can break the password using some certain tools like Hydra and so on and so forth. It can get the password, the login, and log into the remote target without the user knowing. I think this should be using 22, if I'm not mistaken. FTP here, on the other hand, is used for file transfer. You can remotely transfer file from one location to another, which is a protocol. The port number there is, I think, 21. It is used for file transfer. This is used for file transfer. So in this case, if a file wants to be transferred from one place to another, FTP can be used. FTP can be used to transfer this file. That's the duty of FTP. So if you will do all this thing practically, so that you need to understand these basics, so that when we're demonstrating this, you understand this, you'll be reflecting on them. So protocols are like a leeway. It gives you an open access to know what that target is all about. Now, if I run a scan at the target, I discover that I'm seeing HTTP at the target. That means there is a web server. If there is a web server at the target, that means there should be database. If there is database, there should be username and password. Then the attacker now will be targeting things like that to hack. So if we move to DNS, DNS uses it is a protocol that we call it domain name service, or domain name server, some people might call it. What DNS does is it is used to resolve or to convert the web domain name. If you type www, for example, www.host.com, what it does is computer don't understand this language, so it needs to be resolved or it needs to be converted. So once you type this, DNS come on board. That's why when you are setting your IP, if you want that particular target to go to a particular location, there must be a DNS address. So DNS will help to convert this thing you type to an IP address. That's the duty of DNS. So DNS converts the domain name to IP address. The IP address now is simply a number that devices use to talk to each other. So with DNS now converts domain name to IP address. That is the duty of DNS. Human can easily carry numbers, but you can't carry IP address easily. So it comes in to rescue that situation. POP3, which stands for Post Office Protocol 3, it helps us to retrieve our mail from our mailbox. It helps if you open your mail, you go to Yahoo Mail, for you to get your mail, you use POP3 for you to get that. I'll talk on IP separately when we're looking at IP address. The SMTP, which is Simple Mail Transfer Protocol, it helps us to transfer mail from one point to another. Then this one is also not secure. If you see this, you know the target is vulnerable. We have NTP, which is Network Timing Protocol. It helps to convert our time. You can be working in a location where the time difference is 2 hours. So NTP, which is a network time protocol, helps to convert this time to synchronize the internet time. There are some websites, if you go, if it's not accurate, if it is not correct, that website will not open. The internet even will not give you access. That is what NTP stands for. And we'll have a bunch of these protocols. We can't discuss on all of them at this point. So these are some of the highlights. Then let me talk about port numbers before we look at IP. When we talk about port numbers, what do we mean? Port numbers are just these numbers that we are giving. Either you can represent HTTP or AT. For instance, port number, we have what we call source port number and destination port number. The source port number, it ranges from 1024 and above, 1024 above. That is what we call source port number. 1024 and above. This is source. This is source port number. This port number. We have destination port number. Destination port number, on the other hand, anything that ranges from the 0 then to 1023, if you take from here to about 1023, that is destination port number. So destination port number, also call them well-known. Well-known, they are known. They are well-known port number. We know them. 8 is known. That's where it falls within this interval. 443, we know them. They are well-known. You can't alter them. But with source port number, these are dynamically or randomly generated. Devices randomly generate this port number to in terms of communication. So they are randomly generated. These ones are well known. There are many of them. That is what we call port numbers. So let's look at IP, which is a protocol, and this is a very important protocol. Look at IP now. IP is very, very important. in this cybersecurity journey. If you don't know IP, it will be difficult for you to navigate your way. So let's look at IP address here. If we're looking at IP, let me just yank this off. If we look at IP address, what is an IP address? IP. It stands for Internet Protocol. Now, IP is a protocol that works at the network layer. It works at the network layer. Now, most of those protocols discussed initially works at the application layer and transport layer. For the network layer, if you want to know protocols that works at the network layer, IP is an example that works at the network layer. We have ICMP. Okay, ICMP works at the network layer. This protocol works at the network layer. ICMP. This, let me just give a few. Now, ICMP, we will see it when we're doing our pinging. Once you ping, testing for connectivity is ICMP. So let me look at IP first. It's very important. IP, which stands for Internet Protocol. We have two versions. We have IPv4 and IPv6. These are two protocols, Internet Protocol. But I'll dwell today on IPv4 more especially. With IPv4, it is a number that can be represented in binary, it can be represented in decimal, it can be represented in hexadecimal. And how is an IP address represented? It is represented in 4 dotted decimal, or can call it octet. I can give you something like this. Now, each of these segments represent, these are just place values, represent the number. Decimal, when we talk about decimal are just number between 0 to 9. This is a decimal. So, for us to fix an IP address and for us to derive an IP address, if we are representing it in decimal, then I'll give an example. Each of these is made up of an octet. An octet is made up of 8 bits. 8 bits, we can say a byte. So, for instance, each of these X is, let me say, 1118 of them. You can say 1008 dots. I can say 118 of them. See up to 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. This is an IP address, but it is in decimal. This same IP address can be represented in, it is in binary, not decimal. This IP address can be represented in decimal. Decimal, you can choose number between 0 to 9. I can say, for example, 20 dot this dot this dot this. One thing you should know with IP here is an IP address here should not exceed 255. This digit here should not exceed 255. It doesn't exceed 255. So an IP address, you can use decimal to represent them. Decimal, you pick any number between this interval. I can give, let's say, 200.1 something, 4 dot. I can't give 400 or 500, is wrong. Maximum is 255, or let's say, 255 is the maximum you can give here in an IP address. So this IPv4, there are 5 classes of IPv4, but we'll dwell on 3 of these classes. What are these classes? We have class A, we have class A, we have class B, we have class C, we have class D, and we have class C, we have class D, we have class E. But my emphasis will be on these 3 classes here. So class A IP address, each IP has a format. With class A IP, there is a format. How will you know that the IP is belonging to class A? Every IP has what we call a network section and a host section. So for A, the format of class A is N stands for network. Follow with we have H, we have H. That is the format for class A. Class B is N, follow with N again, follow with H and H. And for class C is we have N, follow with N, and H. So these are the format. N stands for network and H stands for host. It is very important because you can't even maneuver your target without understanding IP. So what do we mean by network? Every local area network, a LAN, there is one network for every LAN. There is one network for every LAN, except you go into VLANs that you can separate it into multiple VLANs. We call it virtual local area network. But a network address is simply an address that belongs, that every host must have in a network. It's like a surname. Every family, every person that belongs to a family, there is a surname. You must have that surname. That is a network address. On the other hand, host address is used to identify individual devices within the network. For instance, now let me give, for instance, I might just say 80.0.0.1. Now, this particular IP here, looking at this at this point, if it is this format, 80 here is a network because N it tallies to 80. The rest are the host segment. Now, this host must be unique. Host is like an individual name. Host must be unique. Two child or two in a family. If a man give birth to two children, he won't give them the same name. So every host in a network must have a unique address. If we try it practically, if we assign the same host address, there will be an IP conflict in the network. So the host address must be unique. The network address must be the same. Now, how will you know whether an IP is class A or class B or class C? It is simple. Now, for you to know whether an IP address is class A or class B, I'll give us a range. For every class A IP address, there is a range. The number range between 1 to 126. Yeah, that's what we should have. We take 1 to 126 for the first bit of the first byte. That is what I'm talking about here, is the first bit. So any number that falls within this interval, now you know that IP address is class A. What of class B? If we go to class B, in this case, class B, how will you know what an IP is for class B? You say 128, you take 128 to 19, should be I think 191. That's it for class B. For class C case, the interval here is 192 to 223. This is for class B. Now, what we should be interested here is look at the first octet here. Once you look at the first octet, look at this interval. Once you get this interval at this first octet, it will point to you the particular class which the IP belongs to. Now, if we go by this, I'll give an IP. Let me say I give let's say 110.8.8.1 or .9. Looking at this, merely I'll say this IP address is a class A IP address because 110 falls within this interval. That is how you identify classes of IP address. Yeah, if I come and give something like, let's say 130.0.0.2, in this case, yeah, this first octet here falls within this interval. I won't say this IP is class A. This automatically, this IP address is a class B IP address because this falls within this interval. In the case of class C, if I give something like let's say 193 or 194 dot anything dot this IP automatically belongs to class B. So the first thing with an IP, for you to identify the class, it is to look at the first octet here. Then look at this interval. You just need to cram them, know them, understand them. Man, looking at it, you will know the class in which this IP belongs to. So having known that, every IP will have what we call a subnet mask. A subnet mask, it is that section of an IP address that differentiates the network portion from the host portion. Every IP has a subnet mask, and we have what we call default subnet masks. Default subnet masks, you don't give them, they come alongside once you are assigning your IP. Default subnet masks. Default subnet masks now here, you find out that for class A, the simple way to derive your default subnet mask, Where you see N, you put 55. Where you see H, you put 0. Therefore, the default subnet mask for class A should be what? 255.0.0.0. That is my default subnet mask for class A. For class B, I have 2N. I say anywhere you see N, you put 255. So my 255 here and 255.0.0. That is my default subnet mask. Likewise, for class C, I have 3N, 255.255.255.0. This is my default subnet mask. You don't assign them. They work automatically when we'll be doing our practical. You can customize the subnet mask when we start doing subnetting. At this point, I believe we can identify classes. I also believe we can identify the subnet mask pertaining to a particular class of IP address. If we go further, every IP address, there's what we call private and public IP address. You need to understand that private IP address, these are IP addresses that are used within the LAN. They don't give you routing capability. You can't have internet access with private IP addresses. And they also have interval. You need to understand this interval. So that when you see an IP address, you know that this IP is a private IP address or is a public IP address. But for public IP address, these are IP addresses that are routable. They can give you internet access. You can pay for them. When you are paying for internet service from an ISP, you are paying for the public IP address. How then can you understand which IP is private and which IP is public? For us to understand this, then there are intervals. There are intervals you need to know. For private IP address, private, we're looking at private per class, private IP address for each class. I will take class A. For class A private IP address, let me say A. So the private IP address interval here, it starts from 10.0.0.0 to an interval to, let's say, .0, an interval here till you get to 10.255.255.255. Yeah, that is the interval. Let me put it this way so that I understand it better. So let me put it like this. Yeah, so that's how it is. This is for class A. That is a private interval. For class B, the private interval is given like this. We have 192.16.0.0 follow with 172.192.31.255.255. That's it. Let me put it down so that you understand better still. This is an interval for class B. If I go further, for class C, he also has an interval. Class C has something we call 192.168.0.0 follow with I can say here 192.192.168.0.255.255 is very important. In this case, these are intervals. So if you are setting up your network, like what we'll do, we'll design a network. What we'll be using in that network is this private IP address interval. So with this private IP address, you can assign them repeatedly as you can. So you can use them in a LAN majorly. Use them. I can use one private IP address in a very big location. So these are the intervals. So each time you see any IP that starts with 10, definitely 10 falls within this interval. It is a class A and it is a private IP address. Each time you see an IP address that starts with 172, 172 falls within this interval. It is a class B private IP address. Each another IP address that starts 192, it falls within this interval. It is a class C IP private IP address at this point. So we can identify these intervals, and having understood the identification of this interval, anything that is out of this range is a public IP address. Now, how do we know public IP address? For instance, now let me see, I want to give an IP address within this class of class A. If I give something like 8, for instance, 8.8.8, so let's say 8.8.8, it doesn't start with 10. Assuming this thing started with 10, it is a private IP address, but it's starting with 8. 8 is not our interval here. So every beginning of private IP address for class A must start with 10. Anything out of it is public IP address. Likewise for class B. With class B, it can give something like a 160. 160 is off the track. It is not starting 172. So anything outside these initials, it is termed private, sorry, it's termed public IP address. You need to take note of that. How to identify private IP address and how to identify public IP addresses. Having understood that, there is still a concept you need to understand, which is called NAT. NAT is called Network Address Translation. You know, most of the times we assign private IP address to devices in a network. We say private IP address will not give you internet access, but those same systems will browse. The question is, what is the magic? What is behind the IP address that can give you internet access, but still the system will browse? Now they introduce a concept called NAT. NAT simply means Network Address Translation. The duty of NAT is simply to take the private IP address and translate them to public IP address for it to have internet access. So NAT translating private IP address to public to give those private IP address internet access. There are different forms of NAT. We have what we call static NAT. We have what we call dynamic NAT. We have NAT overload. If you are doing Cisco, you see more of those ones and the configuration. But at this point, a static NAT simply means one private IP address is being mapped to one public IP address. For instance, I might say 10.0.0.1 is being mapped to a public IP address, let's say 20.90.1, let's say 1.4. This is now, it means this system having this private IP address, it can now browse because as it is going to the internet, there is what we call a NAT translation. So now this private IP address now is being converted, is seen now as public IP address. Once it's going to the internet, it uses the public IP address. Once it's returning back to the LAN, it uses the private IP address. That's what we call internal and external. That is the duty of NAT. Then we have what we call dynamic NAT. Dynamic NAT simply means we have pool of private IP, pool of private IP address that is also assigned to pool of public IP address. It's like DHCP. When we're talking about some configuration, dynamic means the IP that will be used to access the internet is not the same IP that will be used subsequently. It is changing. So it's not static like we map one private to one public. With dynamic NAT, it means the translation keep changing. Like DHCP. DHCP is a protocol also that helps to dynamically assign IPs to devices. So once we talk about NAT, dynamic NAT, the translation is dynamic. We also have what we call NAT overload. NAT overload is when you take pool of private IP address, you are heaping it on one public IP address. Once you take pool of private IP address, heap it to one public IP address, you are overloading that public IP address. That is what we call NAT overload. So I believe we've come to a point where we can identify IP, the classes, the private and the public. Let's now navigate to another aspect of our class. Another aspect I want us to look at here, which is also critical, is what we call subnetting. Subnetting. But before I move into subnetting, let me just sketch a small, simple network diagram. Let's just design a simple network diagram. Yeah, we'll see how it looks like because we implemented in our packet tracer. Let me design a simple network diagram. For me to design a simple network diagram here, I'll just clear off this. Let me just take off this whole stuff here. Let's design the network diagram. I'll come here. Let me just see some shapes here. Let me assume this is my switch. Let me assume this is my devices. Let me assume this is another device. Let me assume this is my cable. Let me assume this is another cable here. This is our switch. If you are designing if you are assigning or designing a network, this is a simple LAN. For me to assign IP to this device here, what are the important things I need to give? I give IP, I give subnet mask. Subnet mask. Then, if this device are not going outside this network, I'll end here. If there is no going outside, the conversation is just within. I just give an IP, I give a subnet mask, I end there. But if for instance, now I bring something like a router, let me just use this. Let me say this is my router here. For instance, if it is a router here, let me just use this to be my router. Then this is another LAN here. So this router now, this switch is linking to this router. This switch also is linking to this router. Now, in this type of design, where you are linking two local area networks together, default gateway must come. You must assign default gateway because default gateway is the IP address that this device will use to leave this LAN to another LAN. You must use default gateway. So we'll do it practically when we'll be talking about our packet tracer practical. I will fall back to subnetting, very important. Subnetting. Subnetting is a vital concept that you need to understand. Subnetting. Subnetting. So what is subnetting? Subnetting is just a process of taking a large network, breaking it into smaller networks. Large network, breaking it into smaller network. That's what we call sub-networks or subnetting. In a LAN, by default, in a local, if I'm using class C, the maximum computers I can assign with a LAN is 254. The maximum host is 254 that I can assign to a local area network. But if I want to expand that, I need to subnet. And what if, again, I don't want to use all of the 254 IPs? I just need 20 IPs. I will subnet. So subnetting is to break that large network into smaller networks. And what are the steps for us to subnet? I'll take a simple example. We'll take class C as an example, class C subnetting. Who subnets? The designers of IPs came with what we call CIDR, stands for classless interdomain routing. So it is a method used by internet service provider to assign blocks of IP address to a client. And they always use a slash notation like this. At times you might see an IP address. For instance, you might see something like 192.168.0.0/25. You'll be wondering, what is the essence of this slash? The essence of this slash simply means the IP. This IP is subnetted. It is a block. You will not use default subnet max again here. So how do we derive this our CITR notation? It is simple. Now let's look at our default boundaries of IP. Class C, the network form, the IP format is n.n.n.h. It has 3 networks and 1 host. That is class C. In this case, for us to derive our default subnet mask is 255.255.255. I say where you see H, you put 255.0. That is it. So in this regard, you find out that this is our default subnet mask. So how do we get our slash notation? For us to get our slash notation, this is simple. How do we do it? Now, how many ends are here? Each of these representation here are 8 bits. N is 8. Each of these are 8. So an IPv4 is a 32-bit address. It is a 32-bit address in a sense that this is 8, 8 again 16, 24, plus this is 32. So it's a 32-bit address. Now, for us to get our slash, where you see a network segment, there are 3 networks here. It stands for 8 times 3. So for us to represent this with our slash, we say slash 24. So if I see slash 24, it will not depend the class. If it is slash 24, I will know that there are 3 N's and 1 H. So now, if I'm to write this, somebody might just write this and say, let me put it this way. Let's say 192.168.0./25. It has changed from the default. Once you see class AC like this is just default. Now, this number has been altered. It's no longer 24. It means something has happened here. How do we derive this 25? That's what I want to explain here. For us to derive 25 here, this is a simple mathematics. Now, each of these octets here are 8 bits. Now, I will count 8 ones. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Then, this entire bit here is 24. Now, for us to get 25, 1 bit has been derived, has been collected from the H and added to this 24. That is why we derive 25. So, in other words, we subnet by borrowing bits from the host section. This is also made up of 8 bits. So, the 8 bit here is, if I pick this, let me, let me come back here. If I pick this from here, I have borrowed. So we subnet by borrowing bit from the host part of an IP. This is our network. This is our network. This is our network. This is our host. So the host here will have only one host, and each of them is made up of ones. So if we pick 1 bit from here, add to this segment here, automatically we'll get 25. That's what we'll derive /25. So if we take /26, it means 2 bits has been borrowed. In a simple mathematics, how do you know the number of bits that has been borrowed? Just if it is class C, our default in class C is 24. Then if you see a strange value that is not 24, take this number, subtract from the default, you will get the number of bits that has been borrowed from the network section. So in this case, 1 bit has been borrowed. So we subnet by taking bits from the host section, adding to the network section. That is subnetting. What are the steps that we can follow for us to subnet? And because if you are running scanning in a network, you will not come across only default IPs. You will come across subnetted IPs. So once you see them, you should understand what actually is happening in that network. You shouldn't be confused. So let me show you how you can simply subnet, break this network into little networks. So our first step in subnetting here, I'll give us some steps. What are the steps in subnetting? The first step here in our subnetting is determine the number of networks you want to create. Let's just take an example, 192.168.0.0/25. In this case, how then do we go about our subnetting? The first step for you to subnetting is breaking a large network into multiple networks. How many networks do you want to create? That is the first thing. So the number of network you create, you use a formula. The formula is 2 raised to the power n, where n stands for the borrowed bit. 2 raised to the power n. Now, 2 raised to the power n. In this case, looking at this, it will tell us that 1 bit has been borrowed because the default class C is 24. 25 minus 24 means 1. So for us to get the number of network we have to split this network into, we have to say 2 raised to the power 1. 2 raised to the power 1 automatically will give us 2. This means we have to create 2 networks. That's what it means. Now, in these 2 demarcations that we're trying to split this network to, how many hosts will be connected in each network? For you to derive the number of hosts that will be connected in each network is 2 raised to the power n, 2 raised to the power n minus 2. Minus 2. So now, the first n here stands for the borrowed bit. So we'll say 2 raised to the power the borrowed bit to get a number of network. Now, in this second case for the n, or you can say u, I can use b for simplicity. B stands for borrowed bit. U stands for unborrowed bit. Remember, we have n, h. And there are 8 ones in the whole section. If we borrow 1 year from here, we'll be left with 7. So it should be 2 raised to the power 7, 2 raised to the power 7 minus 2. If you do this, automatically you should get, I think, 128 minus 2. 128 minus 2 should give us 126. It means in every network, we should have a maximum of 126 hosts or computer that will be connected to it. The next step here is we need to determine what we call our block size. Our block size here, what we'll do, we'll say 256, that's the formula. I use 256 minus subnet. I'll explain. 256 is a constant minus subnet. I will simply derive a table that will help us to know what is our subnet, so that we can use it to substitute and solve this thing. Now, it is simple for us to understand where we get our subnet. The maximum bit you can borrow here is 8. 1 to 8, that's the maximum bit. So what we'll do here, I'll take borrowed bits. Here my S will start for subnet. Then this will start for increment, please, because of time. I can't be typing all this is increment. So B is for borrow bit. B for borrow bit. I can borrow 1, can borrow 2, can borrow 3, can borrow T8, 4, 5, 6, 7, 8. These are the bits I can borrow. Now, increment. This is what I want us to understand with the increment. I don't want to bulk us with much mathematics here. For us to get this increment, what I'll just tell us here is, what you do here is, just start with 128. Except I'll go and start converting this. I don't want to spend much time on that. 128, that's what you need to know. Then, subnet here should be 128. We have 128 here. That is our subnet. Now, how then do we get our increment? This is what I want us to do. For us to get our increment, let's take the powers of 2. I'll take it from down up to make it simple. The powers of 2, you just say 2, 4, 6, 8, 10. So just be multiplying 2 by 2. Here is 2. 2 times 2, we should have 4 here. We have 4. Here we should have 8 here to derive this. Here we should have 16. Here we should have 32. 32. You have 64. 64 here. Here we should have sorry. 1. Sorry, we need to start with 1, please. It's 1, 2, 4, 8. Please adjust it. 16, 32, 64. They will not get 128 here. This table will help you in your subnetting. Now, how do we derive our subnet? Because I want to get this value here. For us to derive our subnet, there is no number in before 128 in this our table. So what you do here, just repeat 128 here. For you to get these subsequent values, just be adding this to these values. So I'll add 64 to 128. I'll get 192. So what you do here, now you add 32 to 128. You have 224. 224. Yeah. If you add 16 to 224, you get 240. I hope I'm right. Yeah, it's 240. Then if you add 8 to 240, you get 248. Then if you add 4 to 248, you have 252. 252. 252, 252. It's table guiding your subnetting. Then if you add this, you have 254. 2 plus 252, 254. We'll get this. Then if we add 1, we'll get 255. 255. So you can arrange your own. Now, if in this our case, we borrowed 1 bit. Now I said this is borrowed. Is borrowed. This is subnet. This is increment. So how many bits did we borrow? In our case, we borrow 1 bit. Therefore, our subnet is 128. We'll replace 128 here. So replace 128 here. If we subtract it, we are going to get 128. I hope I'm right. Yeah, it should be 128. Yes, it is 128. So if you borrow 2, you replace our subnet with 192. If you borrow 3, you represent it with this. So, but we will not end at this point. The next phase we are going to move here straight is we are going to get our incremental value. For us to get our incremental value, always start counting with subnet 0. You start with 0. Add this value you got, to this 0. So we'll get 128. We'll get 128 here. It means here should tally with this number. Any number you get here, if it is more than 2, you are out of the game. We have to create 2 networks, and these are the 2 networks. That's a proof. And each of these networks should have 126 computers that will be connected to each of them. So, how then do we now sketch this our network engineering or IP engineering? This is our network. So for us to sketch it here, I'll go down. For us to design, get the IP address, what I'll do here is we want to get our subnet. Subnet is the splitting. And we say we'll create 2 networks, and these are the 2 networks. So what we'll do here, we'll simply say network 0 and network 128. The next thing we'll need to do here is how many computers will be connected. We'll say hosts. We'll have the first host per network. Now, the first computer that will be connected. We also need to have the last computer. The last host that will be connected. So now there's every network must have broadcast. Broadcast is always used. I told us in LAN is used to propagate signal to the entire network. It must have. So we must create our broadcast address. We'll have our broadcast. So our broadcast should be there. So with this calculation, we use it to design our network. So what we'll do now here for that is, for you to derive these values here, it is simple. If you are counting 1, 2, 3, 4, 5, 6, before you get to 128, you get to what? 127. So for you to derive your broadcast here, broadcast is a number before this when you are counting numerically. A number before 128 is 127. That's our broadcast for this value. At the end of this value here, we assign 255, 255. At the end of that IP, you put 255. For you to get a first computer in this network, add 1 to each of these IP here, subtract 1 from each of these here. So with this, I'll add 1. So you give me 1 plus 0 is 1. Here, I will do what? I will add 1. There should be an, okay, yeah, it's correct. We'll add 1, I'll have 129. Then at the last, so subtract here. You subtract from these values here. I'll subtract here. I should have 126. This has confirmed our assertion that this is the first source. The first source is 1. The last source is 126. The maximum host should not exceed 126. This has proven that point. Anything you get outside this value, the number of hosts, you are out of the game. That network will never work. It will not communicate. Then you subtract 1 from 255, you have 254. So, I haven't done this. This is not the end. You cannot use this to design your network because we are customizing the IP address. For us to use this to design our network, we now have 2 networks here. So if I'm using my IP, this is the IP that we are working on. So what we'll do, copy these first 3 segments here, assign this IP, copy this other one, assign. That's how you derive their networks. So my first network, network 1 here, is 192.168.0.0. That's my first network. That's what the router will keep. We'll see them practically. Then the number of computers that I can connect in this network should be the host. The host here, the host, I can say host in this network should be 1 to 126. I mean, the first computer should be 1, second should be 2, 3, 4, 5, 6, 7. Now, if I'm going to the second network, my second network now should be this. If I'm deriving my second network, network 2, my second network now should be 192.168.0.128. We'll copy this, 128, that's the second network. But the first computer, the first IP I will assign in this other network should start with 129 and end with 254. If you give anything outside of this block, that computer can never communicate in the network. So the host here, the first host should be 129 and follow with 254. Okay, 254. Can just see. And the host here for this network is from 129 to 254. We've subnetted. So having subnetted this, you can now use it to design your network, which is what we will use to design our network if you are not working with default IP. So when we are assigning, the first host should be 192.168.0.1. We don't assign 0.0 to a host. This is a network address. We don't assign this one. All these ones say that we use their network addresses. So in a place of this last digit, for each computer, you start picking values from here and be giving, be assigning, be changing it. You don't assign it. This broadcast is used to propagate message if there is a need to propagate any message. That is a simple subnetting when it comes to Class C. If you want to do for /26, which I will do, I'll solve that and I'll end my subnetting at that point. Then we'll switch into some demonstration of some practicals. At least we've spoken enough. Now, I will solve for /26 so that we can get it again. For /26, I'll just wipe. We already know this table. I will not do all these things. So it'll be faster this time around. I'll yank this off. I'll pick this. Let's take 192.168.0.0/26. Now, if I see this, number one is class C. Number two, it is an IP that is subnetted. We forgot to derive our subnet max. It's very, very important, but I'll derive it here. Because you will not use 255.255.255.0 again. If you use that, it will never work. We need to derive a new subnet max, which I'll do it in this case. So, in this case, what I'll do here, first thing I'll do is, looking at this, it is class C. The fourth class C is /24. I'll take 26 minus 24. It means 2 bit has been borrowed. If 2 bit has been borrowed, it means I need to create 2 networks. The first step I'll do here, I'll take 2 raised to the power 2. If I take 2 raised to the power 2, I'll get 4 networks time to create. In this 4 network, how many computers are to be connected? The second step here, if I borrow 2 out of 8, 6 is left unborrowed. So 2 raised to the power 6, which is left, minus 2 should give us, I think 64, if I'm not mistaken. 64 minus 2, I should give us 62. Yeah. The next step here is the third step is we need to get our 256 minus subnet. From the table I derived, when you borrow 2, our subnet should be 192. So if we go by this, it means we are going to have 256 minus 192, which will give us what? If you look at that table, it will give us 64. If you look at that table. Now, for us to get our interval, start always with 0, increment with these values. Yeah, I will add 64 here. If I add 64, keep incrementing, don't end at this point. I will still add this 64 to this until when you keep adding until you get to a value that is equals to this. Once you get to a value that is equals to this, you end at that point. I'll still add 64 to 64, I'll get 128. 128 is not equals to 192. I'll still add 64 again to 128. I'll now derive 192. I'll end at this point. This is 4 networks. It tallies with this 4 network to create. The next point now here is what is the network? I will say subnet or subnetwork. My subnetworks. Now I'll just say subnet works. I'll say you take these values, spread them across. We'll start with 0, follow with 64, follow 128, follow with 192. These are the 4 networks. The next phase here is for us to get our first host. Our first host, then we'll get our last host, then we'll get our broadcast. How do we derive this? Now, for us to derive this number is 64. The number before 64 is 63. Then the number before 128 is what? 127. The number before 192 is what? 191. The number before you end with 225, as I said, you end it with 255 at 255. You end it there. Then how do you get your first source? Just add 1 up to each of them, subtract 1 down from each of them. What I'll do here, I'll add 1 to this, gives me 1. I'll add to give 65. I'll add here, I'll get 129. I'll add here, I'll get 193. I'll subtract 1 here, I'll get 62. Perfect. It tallies with this. The host shouldn't exceed 62. From 1 to 62. If you add 63, it means you are entering the broadcast. It's an error. It won't give you the right result. In this case, you subtract 1 here, you have 126. From 65 to 126 is 62 if you count it. So you shouldn't exceed that. Here we should have 190. 190. Here again we should have 254, 54. I think that's all we should have here. We've designed this. Now, how do we pick this to design, start building our network? For us to pick this to build our network, we need to derive our subnet mark, which I forgot the last time. Our default subnet marks in class B is class A is class C is 255.255. If you forget how to derive it, just know that class C is N, then H. Where you see N is 255. When you see H is 2. So my default subnet mark is 255.255.255.0. But we will not use this. Once you subnet, this is cancelled. The new subnet mark should be 255.255.255. Now, in the place of this 0, where we borrowed and did our computation, you take this value and place there. That's where you derive your new subnet marks. This is our new subnet mark. This is what you use in designing your network, not this. If you use this, if you use this, it means everything you did here is just rubbish. It will not work. Everything will be default. You are customizing this IP. So for you now to map out your different networks, the first network here is 192.168.0.0. That's the first network. I say copy this first 3, then pick this value. The second network here is 192.168.0.64. That's our network. If we go into a router, these are the things that you'll be seeing in a router. They are already programmed inside the router. You don't need to assign them. That's why if you make any mistake, the network can never work. The third step here, the third network is 192.168.0. I think we should have 128. Then the fourth network here is 192.168.0.192. These are our 4 different networks that will be placed in a routing table. That is it. So the host, the computers now, if you start assigning IPs to the host, the first IP, I can't come here and just give 20. Or let me say, I can't come to this first network and give 200 or 100. No, this is my range. The first host should be this, the last host. So I can give 1, 2, 3, 4, till N at 62. That's my maximum. Yeah, the maximum here is 65 to 126. All right. Then the year should be, we have 129 to 190. Yeah, we should have 193 to 254. This is what we derive. At this point, we cannot design our network. So should in case you start seeing different subnet marks, it should come to your mind that this thing has been subnetted. For instance, I can derive a table of different subnet marks. If we have something like, let's say, 255.255.255.0/24, you know what is in your mind. In this case, you know it is default, and so on and so forth. You can start deriving different subnet marks. If we take the subnet marks now for /25 should be 255.192/25. The next subnet marks 255.255.255. No, this one should be okay. This one should be 128. This one should be 192/26, and so on and so forth. If you take /27, you have 224. If you take /28, and so on and so forth. That's how you derive new subnet marks. So at this point, I believe I've spoken a lot theoretically. We need to fall into a packet tracer and demonstrate what we've been talking all this while practically, and see how some of this concept can be put into perspective. So I'll stop sharing of this screen. I'll switch to my packet tracer. I don't know if I can go ahead. If I can go ahead, I just need a thumbs up here. If I can go ahead with our packet tracer. Okay. Let's go ahead with our packet tracer to demonstrate some of these things. I'll switch to my packet tracer. If you can see my packet tracer, I need a thumbs up here. You can see it. Okay. Okay. Okay, perfect. Let's translate all those discussion into a practical perspective. Now, this is the interface of a Cisco packet tracer. It is used to simulate your network before you implement it live. So I'll quickly run through this environment. You can use this symbol here to pick your devices. These are different devices here. If you look at this base section, these are our routers. If I click here, this is PC. These are a laptop. These are different devices depending on what you want. These are our cables, depending on the cable you want. I'll just talk on essential devices that we're looking at. We're not doing core Cisco configuration here. We're just doing the implementation of a LAN. We have these are clouds. These are other devices that you can go for. So basically, we look at here and here to pick the device that we want. If you need a switch, these are other devices here. And at this point, I can cancel what I want here. If I don't want a particular device, these ones, I can delete them. Yes, like my text, I can use to type something. At this point, I cancel it. Now, I will pick a router. Let me first of all pick a switch. This is a switch. I'll take a switch here, drag it to this point. Once I drag a switch to this point, I'll pick my devices. These are my devices. I can take my laptop. This laptop. I need a desktop. Basically, these are the connections we'll do here. First, we'll do a simple LAN before we extend it. This is my cables. These are my cables here. Normally, in networking, there are different cable configuration. If you are connecting dissimilar devices, we use straight cable. If you are connecting similar devices, we use what we call crossover cables. These are different forms of cables here. This is a straight cable. This is a crossover cable. These are fiber cables. These are different serial cable connections. This is a console cable. To make it simple, for simplicity, I'll pick auto. With auto here, it will automatically give you a connection. You pick this. I'll pick this here also. I connect here. Pick this. I connect here. At this point, we've established a simple connection here. With this simple connection, the amber symbol means they are still trying to initiate their connectivity at this point. Connectivity is trying to be initiated at this point. Once it is initiated, it will turn to green. So at this point, what we'll do here is, let's see how we can assign our IP address. Let's take a simple //25 that we worked with. /25. What we'll do here, I'll come here. I think I need a text. I'll type here, say 192.168.0.0. I'll say /25. This is what we are working with, this /25. So at this point here, now it's just a simple LAN that we are designing. That means every device must belong to this network. So what we'll do here, for simplicity, I'll make it very simple. I'll just click on this device. Once I click on this device, I'll go to desktop. Once you get to desktop, you go to IP configuration. I don't know whether they are seeing me. At times they are lost.
No.
Yes, please. Are you seeing my? I don't think you are seeing the other configuration.
Hello, can you hear me?
Can you see?
Yes, we
No,
can
I'm
see.
out
I
of
can
this
see.
point. I don't think you are seeing. Let me reshare to know where you guys are seeing. I don't think they are seeing this thing. I don't think. Let me reshare. This is where I was. This is where I was. Yeah. After clicking on the PC, it will now take you to this particular interface. At this interface, we have DHCP, we have static. For you to assign your IP address, you can assign IP using static or DHCP. DHCP means you will not assign any IP. Automatically, the DHCP server will assign IP for you. But want to statically assign IP address, excuse me. For us to statically assign IP address, I will type 192.168.0. We're using /25, which gave us two networks, network 0 and network 128. The first host there was 1 to, I think, was it 126? These were the hosts. So I'll give 1 as the IP. If I come here, it gave me the IP address automatically. Sorry, the subnet mask automatically. But we are not working with this subnet mask because the IP has been subnetted. So we have to change this based on the design we had, based on the subnetting we had. So /25, this place should be 192. There's no need for gateway here. There's no router. We are good to go with this particular device in this case. So once you assign this, we've given an IP to this device. You close this, you assign for the second device again. I'll go back to my second device. I'll share. I pick the second device. Let me take this PC. Once I pick this PC, I click on that PC. After clicking on that PC, what happens here is I will take us to desktop. I don't think you are seeing. Let me reshare again so that I can get it back. You are not seeing what I'm doing. Can go back here. This is my desktop. Once you click on that, you go to IP configuration. Now we assign 192.168.0.2. The subnet mask will change it to the 192. From this point, we've assigned IP to these two devices. We are to test for connectivity. For us to test for connectivity, what we have to do, we have to ping these devices. Pinging this device to test if these devices can talk to each other. This is the IP. If you can see it there, I gave 192.168.0.1. Okay, this is /26, not /25. Since we are using 192, this thing should be /26 rather. /26. So now, for us to test if these devices are actually talking to each other, now we have to ping the device. Ping, we use a protocol called ICMP. If you open this device, you take the IP address of this other device and ping it at this terminal. So we'll open this device. I'll click on this device to test if these two devices are talking to each other. For us to do that, then we are to ping this IP. And for us to ping this IP, I'll come back here. I will now say, ping the IP. I'm in this device. I'll go to command prompt. Once I go to command prompt, where's my terminal? Is this thing corrupt? It's horrible. I'm not seeing my prompt here. This thing is corrupt. It's corrupt. I don't know who is following. Yeah, I was supposed to ping. I can't get my pinging terminal here. Let me go back. It's horrible. Let me go back. Command prompt. My prompt is supposed to appear here. It's not showing. Please, you need to try it on your own. There's something wrong with the packet tracer. I need to just type the IP of the second device. If you are following up, please, there's an issue with this my terminal here. That's why. So you need to ping it to see if they are talking to each other. So you tried yourself. My terminal is not coming up here. I'll check what is the error, why the terminal is not coming forth. But we'll do it when we're dealing with Kali Linux. We'll see the ping in there. So we'll fall back. Let me bring a router then to see how these things work with the router. For us to bring a router in the scene, I'll come back here. I'll go back with my router. Go back with my whole configuration. Now, for these things to work, I don't know why that thing is not, the terminal is not showing. So for it to work, what we'll do here is you now bring another switch here. You bring another device. You link it. For you to do that, okay, for us to do this, we'll bring a router in the midst of this connection and bring a router here. With this router, we go to auto connect. The auto connects. You pick here again. You link on this. This is the auto connect. We are bringing a router in the midst of this connection. So in this case, we also need to give some devices here. We need to bring some devices here to link them up. Also auto connect here. Also auto connect. Now, since we are using /26, /26 has 4 networks. Network 0.0, 64.128, and 192. So let me use network 192.168.0.64/26 in this regard. So this is a design here. Now, this router is not communicating to these different networks. How then do we enable this router to communicate to the different networks? For us to allow the router to communicate with the different network, we need to do some configurations in this Cisco router. And for us to do some configuration, use your console the right way. If it is live, you take your cable, you go here, you take your console, connect, you go to your RS, link it to the console terminal. That's how it is done. You now control the router from the console. But I'll just keep it simple. I remove my console, remove this, delete. I click back here. I do have 2 interfaces here. This router is not yet up. So we need to bring this router up. To make this router come up, we need to log into the router. Either I go through a console or I just click on this. In live device, you must go through the console. So for me to do this, I will click on this router. Once I click on this router here, an interface will appear. Once this interface appears, let me show you the interface. Once this interface appears, what we'll do here is, this is the interface. Router, this is a CLI. You go to your CLI of that router. I'm inside the CLI, you go into a CLI. A CLI is the interface where you do the configuration in this router. In this interface, there are some configurations I will do. At this prompt here, the router has no existing configuration. That's why it's giving us this interface. I will type N, that's no. I press enter. Press enter again. One time. This is a router terminal. In this router terminal, there are some series of commands I need to type here. What are the commands? This prompt, we call it the user mode. This is the first interface in a Cisco router. I will type enable. I want to enable. I use my tab key to complete the spelling. Enable comes up. I press enter. It takes me to a different mode. This mode, it has taken me to is called the user exec mode. In this user exec mode, you can see the configuration running in the Cisco router. Now, in this particular mode, our major configuration to affect this router entirely is not done in this particular mode. I will navigate to what we call a global configuration mode. The global configuration mode type conf t or conf. You say conf, you press your tab button, you complete the spelling. Conf t, configure terminal, tab will complete that spelling. Or you just say conf t. I'll press enter. This is the global configuration mode. In the global configuration mode, I can now start configuring my router. Now, in this router, there are two interfaces. How then can I see my interface in my router? For me to see my interface, now I don't even know the interface. I will go to my user exec mode. For you to leave the privilege mode, there is a command you will type. You can just type Ctrl Z, or you type, yeah, let me say Ctrl Z. Ctrl Z, you press enter. It has taken me to user mode. That's Ctrl Z. So once you type Ctrl Z, I want to know the interface, the ports that this router has. What I will type here, I will type show. I want to see. I say IP. I'll say interface. At times, if you don't know what to type, you can use question mark. So you say show question mark. It will give you what. There are a whole lot of commands here. I'll say show IP. If you don't know what next, do your question mark. It will give you what will follow suit. Show IP. I want to see interfaces, the status. I'll say IP interface. My tab key. I'll still use my question mark to see others. What do I want to see in the interface? I say show interface brief. Let me just see interface brief. Yeah, it's telling me that these are the interfaces, the Ethernet connection in this router. I have this. There are two connections are connected to the two network, which is Ethernet, gigabyte Ethernet 00 and gigabyte Ethernet 0/1. It tells us that these interfaces are down. That's why they were showing red. We need to bring them up. Now they are shut down by. We need to bring them up. So for us to bring them up, you need to note their interface. I'll bring these two interfaces up. No, the first interface I want to bring, I'll type, go to your global configuration mode. In your global configuration mode, you call up that interface. I will say conf t. This time around, I use my configure terminal, enter. At this point, for me to bring that interface up, I will say interface. My tab will help me. Let's just say IP interface. Yeah, IP. No, we say interface first. Interface, we have, these are the interfaces. G0 gigabyte/0 and gigabyte. has come back. Okay, now we are on this interface. Once this interface is up, for us to bring it, once we bring this interface, for us to make it active, what we have to do here, we say no shutdown. It is shut down. I can use my tab to complete my spelling. No shutdown. I press enter. It tells that the interface state is up. I press enter again. This interface is up at this moment. I want to also bring the second interface up. Now what I'll do, I'll type exit here, exit. I'm leaving this point, enter. I've left that particular interface mode, this so-called interface mode. I'll now type the second interface. I'll say interface G0/1. This time around, I press enter. I want to bring it up. I say no shutdown. No shutdown. I press enter. It has come up. Now, if you go back and check their interface, you discover that they are up. And if you look at our connection, they'll be green. So I'll exit. I can press Ctrl Z. I use my up arrow key to bring up those commands I've typed. I don't want to repeat them again. As a show IP interface brief. It tells us that the interfaces are up now. Initially, they were down. If you look at where we did before, they were down before. So, but bringing them up, now they are now up. But no IP is assigned to those interfaces. We are to assign IP to our interfaces. So we are now going to use those IP that we designed to assign to our interface. Now, what we have to do here, I will just stay here. I know those IP. I will just remember them and use them to assign. Let's use 192.168.0.0 as one of the network, 192.168.0.64 as the network. And the first network, the host there is 1 to 1, I think 1 to 62. The second host there, I think you should start from 129. Sorry, you start from 65 because if we're using /26, the first host start with 1 to 62. The second host start with 65 to about 126 thereabout. So if you note that there are two LANs, so we assign these two networks to these two LANs. So what I'll do here is go back to my global configuration mode. In my global configuration mode, I'll type Conft, enter. At this mode, I want to change the name of this router. Let me change the name. I want to rename the router. There is a command called hostname. I'll say hostname. Hostname, I can give it any router name. I say head office. Head office. I'll press enter. The name has changed. The router name has changed to head office. Change the name. Now let me just assign the IP first before doing other configuration. For me to assign the IP, you invoke the interface. You must be on the interface mode. I will call interface G0/0. Enter. For us to assign IP address, we'll say IP. There is a command called IP. I'll say ADD. I use my tab to help me address. IP address. If I don't know what next to type, I'll put my question mark. It tells me type the IP address that you want to type. This is the IP address format. You say IP. I'll now follow it. I'll use network 0 here. 168.0. You don't give 0.0, but use the first source. If I want to use the first source, I'll say .1. I say .1 for my first source. I don't know what next again. My space, I put question mark. It tells me that what should come next is my subnet mask. What is my subnet mask? After subnetting, there is a subnet mask. Our subnet mask is no longer default subnet mask. It is 255.255.255. Since it's /26, that way the subnet mask should be /192. If you make a mistake, it will change everything upside down. So you should be careful when assigning this. So at this point, I've given an IP address to this router. I'll press enter. I've given that. Perfect. On the other, because the interfaces that are connected to this router, I will go out of this interface mode. I'll type exit. If I type enter, I call back the other interface. If I don't want to start invoking this command, I use my up arrow key on my keyboard. Keep calling those commands that I've initiated. This is the one I need to use. In this case, we'll give 192.168.0. The host from a different network. The first network, if you can remember what was subnetted, the first host is 1 to 62. We shouldn't pick any IP. If you pick any IP and assign, if I just assign similar IP, it tells us that there is an overlap. So let me just try it and see what we can, whether it will give us an error. Let's say 2. Let's say 255.255.255.192. There's an invalid. Where is it? IP. Okay, there's no IP address command. Or say IP address 192.168.0. Let me just repeat this. What I will give an error: 255.255.255.192. Let's just see something. Did you see the error? As I was saying, I said there's an IP overlap. If you address very well, you will experience something like this. There is an overlap because I've understood IP address very well. I know how to assign them. Overlap. Once you experience overlap, it means, in a router, the different interfaces point to different networks. So you can't take from 1 to 62, pick any IP, start giving to interface of a router. You need to leave that block. You divert to another block entirely. So for us to correct this, if we now come in, I don't need to start retyping this thing. I'll do Control B to go backward. There is a command called Control B to go backward. Now, I'm not taking anything between 1 to 62. If I take anything within that interval, you'll be giving me overlap. Let me skip to network 4. The first host there is 65. So I will change here to 65. I press enter. Perfect. It has worked. There's lab here. So we've assigned IP to the interface of our router. Now let's go to our routing table and check these two networks. I didn't assign network, but you will see one that's in the routing table. Because these things are already programmed in the router. Any mistake you make, it will give you an error. Let's do exit. For you to do anything or to show or to see anything running in your entire Cisco router, you must be in the user mode. I will type my exit here, press enter. This is my user mode. User mode is always without hash symbol. I will do show IP route. So I'll show IP route to see my routing table. Enter. This is my routing table. Let's interpret what this thing is telling us here. It's telling us here that T is directly connected. There is a network that is directly connected. And this is the network. It's /26 interface to that network. Remember, I gave 0.0 and to this particular interface. Now, this is just a look back interface. It's a logical interface. We are not dealing with this for now. Look at this C again. It's another directly connected. You find out that this is a second network. You automatically assign it. Subnetting will carve out these things. They are built inside the router. So once you assign the right one, it will give you the correct result. So it has fit the networks inside the router. So each time a router wants to move a packet from one place to another, it checks in the routing table. Do I have an exit to that network? Once you have an exit, which interface will I pass to go to that particular network? That's the duty of a router, is to be moving the routing packets. So automatically, routing table, we've assigned this perfectly. At this point, let's fall back to our devices. Because the first configuration we did, we assigned IP without without gateway. Now, this IP address we gave to each of this interface is the gateway. So when we talk about gateway, is the entrance and exit point of the network. So our gateway here for this network, this interface, which is this interface, the gateway here, it is that IP that we assigned. We assigned, I think it was 1 at the interface. The other one was 65, which I gave to the other interface. That is the gateway. Now, let's go back to our device to see how these two networks can talk to each other by assigning this different gateway. Wonder why my pinging is not working. We could have tested this. Okay, let's go back to our host. I'll close this environment. I'll just go to my desktop. When I get to my desktop, I'll pick one of the hosts. Let me just show us something here. Initially, those posts were all red, but for the fact that they are all green, it tells us that there is communication in the network. It shows that the devices now are talking to each other. That's what it means. So what I did here, to map this my network, I'm just designing my network. So to map this network now, that's the topology. We'll talk about network topology. This is the topology I'm designing. I'll come here to give a proper topology, a design in this, a documentation in this network. I will say this particular line is one of the interface. Is going to a particular network. Let me know the interface here. I can place my cursor here. My cursor should be able to give me this interface here. It should be gigabyte 0/0. And this 0/0 here is pointing to network 192.168.0.64. So I'll come here. I'll document this. If somebody sees my diagram, I'll say 192.168.0.64. This is a network /26. This is a network. Now, this is the network for this. I can document here. This belongs to 192.168.0.0/26. It's my documentation. I'll go further. I can now assign the IP. I can document the IP here is .65. If somebody sees it, he knows what is here. The IP here is .1. If somebody sees it, he knows what is here. This is and so on and so forth. Now, for us to properly set up this host, for this host to intercommunicate, because the router is separating them, you need default gateway. You assign your default gateway. What is the default gateway? It's just the IP address of this interface, the IP that we give. Remember, look at this, that black that screen on the board, that black screen. Now you find out that you see the interface there. The interface of G0/1 is 192.168.0.65. That is the default gateway. That's what you assign to each and every host in that network, in that side of the network. For the other one, you assign as a default gateway 192.168.0.1. That's what you assign. So quickly, what we'll do here is I'll just assign in one of the hosts. I can't do for all of the hosts. So for us to do this, what I'll do here is I'll go to the host. When I go to the host, when I click on desktop. When I click on desktop of the host, now what I'll do there, you just go there and change the IP. What we'll do there is change the IP. Go to your IP configuration in that host. You go to IP configuration. In this place, what we'll do here is the host here, I've already given 65 to my router, so I can take from 66, 67, 68, 192.192.168.0. I'll say 66. Yeah, remember, this thing is subnetted. You shouldn't leave it at this point. It should be 192. Then this will need default gateway, because that IP address of the router is the entrance and exit point. That is our default gateway. So give 192.168.0.65. For the other network, it was 65. That should be our default gateway. DNS, yeah, you don't fabricate DNS. If you are going to the internet, DNS will be given to you. It is taking you to the web server, the domain server. That is what you should assign them. We'll have public DNS of 8.8.8. That's the Google DNS 4.4.4. But if you are setting up this network, if you are setting up a network within your office, DNS service provider will give you the default gateway. In other words, at times we can use the IP address of our router to work. So, but if you assign the DNS, it means you are giving that system a location to the web server for the system to be able to browse. If there's no DNS, we are good to go in this case. You go to the other network also. In the other network, I can close this. I close this. I go to the other on the other network. For the other network, what I'll quickly do there is I will now assign the gateway. I'll click on this same host, this network based on this. I'll click on this host, one of the hosts here. You pick one of the hosts in this section. So I can pick one of these hosts in this section. I pick it here. Once I pick, I click on, go to your desktop still. Once you get to your desktop, you will now go to IP configuration. If you go to IP configuration, what you do there is you now reassign the default gateway. If you reassign your default gateway, let me share it back. If I go here, I shall come here, then I give my default gateway. So what I'll do here, for this other host, you now go and assign yes 192.168.0. I gave 2 to the router. So sorry, I gave 1. I can give something 5, anything you feel like. Then I change this default, the subnet max to 192. My default gateway should be 192. The IP of that interface linking to that network 0.1. That is it. I am done with this. Assuming my pinging is working perfectly here, I could have gone here. I could have gone to my this desktop. Let's see it again. Close here. I could have gone to my command prompt. I don't see why it's not showing. Now you ping. If you try it yourself, you can attempt pinging. So what we'll do here is on this host, try to ping the IP address of that router. Each of them to see who can reach the router. If you can reach the router, it means it can go out of the network. That is how you test your connectivity. So at this point, I think we need to take a break. If there are questions before we come to the next phase of the bootcamp, if there are questions, it will be open for questions. Then we'll go for break. When we'll come back, we'll now fall into Kali Linux, how to network our virtual environment with the concept of IP address, how we can network our virtual machine, the different networking formats, NAT, host only adapter, bridge, we'll test them there. We'll start our Kali journey from that point. So I would like to pause at this juncture. If there are questions, the line is open. Some queries, then you can ask, then we'll go further. We'll take a break before coming back. So please, you can project some of your questions. Let's see if you can answer them. Please project your questions. No, I can't. Please, queries.
Hello?
Okay,
Hello?
if
Why is my camera is not working?
okay, they should get me the response from them. Somebody's asking a question. I can't get. They should give me feedback on that question. Yes. Okay, please go ahead. Somebody's asking a question. Can't get it. You guys can't get a feedback.
The voice is gone loud.
Please ask. I'm ready to. Please, you can just type if you can't get it clearly.
Gabriel, we can hear you. Please write your question or you ask it. Okay.
Okay, I think his own is not a question per se. He just said we can move on to the next phase of the editing. He's just kind of appreciating and saying we can move on.
All right. It will be a very nice it will be a very wonderful thing to move on with the section. All right. Nevertheless, some of the people that have been here for like 2 hours and the facilitator needs to at least have a coffee before we can proceed. All right. So it's just a way to help us revitalize ourselves and then come back for the next section. Thank you.
Yeah, that would be good. At least the facilitator needs to rest, because I think he have given us the best and the basics. So I think that's good.
I like the fact that you have been getting values since morning till now. All right. So please, is there any other person that have any question to ask or anything at all? You can just go ahead and or you just raise your hand so that we ask you to go ahead so that we wouldn't crowd the place.
Oh, okay. What is the pending question that I can respond to them so that we can take a break? What was Gabriel saying? Hello, guys. I think we need to take a little break. We have a 15-minute break. We'll return back. The next phase of this journey is we are switching to Kali Linux. We are switching to Kali Linux to set up that environment, to network the environment, and start the journey of Kali. There are a whole lot of configuration I can do in a Cisco router, but our goal here is not Cisco networking. It's just ability for us to play around. Else, I couldn't have done this. For us to see some of these stories I've been talking practically. I'm sorry that my pinging, my terminal couldn't show up. I could have tested the ICMP protocol, how the devices talk to each other. That is the only glitch I had. I think my packet tracer had an issue with that. So please let me have a 15-minute break. So return back. This is 3:10. So with 3:25, the line will be open back. We'll return back. We'll fall on Kali Linux. Thank you all for having that patience and your time.